Hey folks, welcome back. So in this video, we're going to be talking about how we can solve something called literal equations. And we're going to be using the same skills that we've been forming with solving linear equations, linear inequalities. The only difference is now we're going to be working with an equation that looks a little bit more complicated, right? So one of the most frequent ways that we see math in the real world is through something called formulas, right? And we've all dealt with formulas before. This is probably something that you've seen on like a lot of like classic math art, right? Something saying E equals mc squared, right? This is this is a formula that Albert Einstein created that showed a relationship between energy, the mass of an object, and the speed of light, which was constant, right? So that just means that this letter is representing this really big number that nobody has the time to write out. Another formula that we've seen a lot in the past is something called y equals mx plus b, right? So a formula is just an equation that describes an important mathematical relationship. And it's so important that we found that we needed to actually abstract it because we use it in so many different settings over and over and over again. So let's think about formulas as something called literal equations. So because formulas show a relationship between two or more unknowns, we can also categorize them as what we just called them, literal equations. Right? And a literal equation is just an equation that involves two or more variables. So I just want to highlight that, two or more variables. So whenever you have like an x and a y in an equation, or an x and a c in an equation, right? Anytime you have more than just one letter going on in your equation, that's how you know that you have a literal equation going on. And oftentimes when we're dealing with literal equations, we're dealing with formulas. So we can treat formulas like literal equations and use them to isolate different variables depending on the context of the question. And we call the variable we're isolating the variable focus. This isn't really like a technical name. It's just what I like to call it so that when we talk about it in the future, it's a little bit easier to kind of talk about what we're doing. All right, so let's look at an example. So let's say that I'm given this equation right over here. So this is my literal equation, 24x plus 2y equals 48. And I know that this is a literal equation because I have two different variables going on, right? I have an x and I have a y. So I'm just going to do the same thing that I've been doing before, where I split my equation into a left-hand side and a right-hand side. And what's different about this equation and any previous equations I've solved for is that this tells me specifically to solve for y. So because I'm solving for y, y is going to be my variable of focus. So let me just annotate that, variable of focus. So I'm just going to try to isolate y. So I'm looking at my equation. I see that my 2y is on my left-hand side. So I'm going to get rid of everything on my left-hand side that doesn't have a y. So that means I'm going to get rid of this 24x. So I'm going to subtract 24x, subtract 24x. When I do that, this cancels. I'm left with 2y equals 48 minus 24x. Now, I don't combine these because they're not like terms, so I just write it out 48 minus 24x. Great. So now I want to just divide by 2, right? So I'm going to divide the whole right-hand side by 2. So I get y equals 48 divided by 2 is 24. Negative 24x divided by 2 is minus 12x. So this would be my literal equation rewritten and solved for y, right? So I know that I'm done because my y, my variable of focus, is actually isolated completely. Okay, so you have a u try over here. So this is a level mild, right? It's the same equation as before. The only difference is that you're solving for x now, right? So take a minute, pause the video here, try this on your own. You ready? Let's try this. Okay, so like I said before, this is still a level mild, right? So this is a first level difficulty kind of problem. I'm going to split this up into left-hand side, right-hand side, and I want to figure out which term has my variable of focus x in it. Right, my variable of focus is right over here with this 24x. So I'm going to get rid of everything else on the left-hand side that doesn't have an x. So I'm going to get rid of this minus 2y. Right, and so when I do that, I get 24x equals 48 minus 2y. And remember, I can't combine these because they're not like terms, right? This has a y, this doesn't have a y. So I know that I can't combine them. Now I just want to get rid of this 24, so I'm going to divide everything by 24. I got x equals, so this is 48 divided by 24, that's 2. this is negative 2y divided by 24, right? I know that I can simplify this by dividing out 2 in the numerator and denominator, so this is just going to be minus y over 12. And then, so this is going to be my literal equation solved for x. All right, we have a couple more mild questions, right? So let's try this out. Once again, pause this video, and when you're ready to check your answer, unpause and review your answer. All right, so let's look at this. Just going to split my equation down the middle, right? It's saying to solve the following equation for y, so I know my variable of focus is going to be y. So I'm going to look for my term with y, so that's 4y. And I see that I have a 3x over here, so I'm going to get rid of this because that doesn't have a y. So I'm going to subtract the 3x. I'm left with 4y equals 17 minus 3x. Remember, we can't combine these terms because they're not like terms. All right, well now I see that I'm multiplying 4 with y, so I need to get rid of this 4 by dividing out the 4. So I'm going to divide everything by 4. And so I get y equals, I know this looks really ugly because it's a fraction, just keep it as a fraction. It's not going to be the end of the world. So I get 17 over 4 minus 3x over 4. Okay, if you wanted to convert it to a decimal, you could have also written it as 4.25 minus 0.75x. In my opinion, I actually think that this looks worse, so I'm just going to keep my equation in fraction form. Right? If you wrote it in decimal form over here, that's totally fine as well. All right, let's look at another U try. Once again, pause the video here when you're ready to go over your answer. Press play. All right, so once again, same equation as our last U try. The only difference is our variable of focus is x now, so I'm solving for x. So same kind of thing, just going to split down the middle, okay? On my left-hand side, my right-hand side, and I want to find my term with my variable of focus in it, and that's this 3x term right over here. So I'm going to get rid of this 4y over here because this doesn't have an x. So to get rid of plus 4y, I'm going to subtract 4y. I get 3x equals 17 minus 4y, right? We can't combine these because they're not like terms. And then I just need to get rid of this coefficient 3, so I'm going to divide by 3 everywhere. And I got x equals 17 over 3 minus 4y over 3. I can just leave it as a fraction, not going to be the end of the world.